I'm Alex. I'm in the customer success team here at OpsMill, so looking after customers and helping out in the community where available. And what we'll be talking about today is how to use Infrahub with some populated data already, and how we can utilize the data in the platform to generate configurations that can be delivered to devices so that you could have a functional network, and really have an overview on how to develop against Infrahub, as well as different tooling around Infrahub to allow to make network engineers' lives better, and also some key features of the platform that make it really interesting for network engineers and making it useful and a tool that you'd want to use going forward. So what is Infrahub? I won't talk long about what Infrahub is at the, so we can get on into the details, but a quick overview is Infrahab's a data management platform that allows you to define your schema in a flexible manner, so you can define different attributes and different nodes within the database and what attributes each of those nodes have, and create custom relationships. So you're not fixed to one point, one schema. There is also the ability to manage everything around the database. So typically you would have different tools doing different parts of the job. You'd typically have Ansible pulling information from a data source and then rendering that configuration outside of the platform. Infrahub brings all that into one place, so you can have the data that sits alongside the templating and artifacts, so that if the data changes, the artifacts and the resulting artifacts are changed with it. We have versioning, peer review, and integrated pipelines that you'll see within this webinar as well when we go alongside it. And because of the flexible schema, we can really do cool stuff around building a service catalog point of view and services within Infrahub that actually generate information within the database on an automated basis. So it's a quick overview, but what we're really trying to do is combine a few different tools. GitOps and infrastructure as code provided flexibility in the past for network engineers, but there was no structured database. We had to provide workarounds for that or store some data in different tools. And then Source of Truth and CMDB tools offered structured data, but lacked flexibility, etc. So Infrahub is really that data platform that everything can talk to, and then everything is version controlled within Infrahub as well. So what I'll do is start with the technical part and talk through what we're going to be showing you today. It's mostly technical stuff, so if anyone's looking to try Infrahub, the good news is the whole lab is available for you to run as well. So after the webinar, you can go and spin up the lab and play with it yourself and have exactly the same experience as I will be showing. So what are we going to do in this webinar? So we've already got Infrahub set up in the background. It's got schemas that are built using our schema library. So if you're wary about developing your own schemas, we have schemas available that we've put together that are common use cases across multiple businesses that extend from everything from device to location to more complex topics like BGP, OSPF, and things like that. So we'll be looking at some Infrahub skills. We'll be looking at how to extract the data from Infrahub using GraphQL, and then we'll look at creating network artifacts. So what are network artifacts? So they're actually based on transformations. Transformations, there are two types of transformations. There's a Jinja transformation, there's also Python transformations. And a transformation is really tying together the query to some logic to produce an output. So in what we'll be showing today, there will be a GraphQL query. That output of that GraphQL query will be passed to a Jinja template, and the Jinja template will render some configuration. You can use these templates for a lot of different purposes, creating documentation. You can create, with the Python transformations, you can create other data objects like markdown files. You could create CSV files, etc. So transformations and these artifacts are not only for configuration, that they can be more widely used. So what we'll be looking today. So we've learned a little bit about transformations and we'll go in as well in more depth, but we have a fictional network here that we have two switches, they're connected via OSPF, and one has a client and one has a server. It's very simple, but it's to learn the basics. Okay. So if you were to go away and spin up this lab yourself, it takes a few minutes, and then you'll have this start button on the right-hand side down here. So this platform is very intuitive to use. We've created this lab so you can walk through yourselves, but it also allows us to demonstrate it to you as well, demonstrate these concepts. We have Infrahub here. It's loaded the web page by default, and there's also some instructions on the right-hand side. I might refer to the instructions every now and again to maybe copy some bits to make the webinar run more smoothly, but it's intended so that if you were doing it yourself, it's a step-by-step tutorial on how to extract data from Infrahub and create artifacts and so forth. So you might see me reference it a few times. So firstly, we're going to learn about GraphQL. We have an Infrahub instance, and we can log in to that instance down the bottom left-hand side, and the username credentials are admin Infrahub. So it'd be the same if you spun up Infrahub locally yourself. So I'll just mind my pop-ups. Okay, so now we're inside. This database is already populated. We're not going to do schema development in here or populating data. This is an Infrahub, as if you were interacting with a database of your own. It has data in. What do we have? We have some network devices, like two switches here. They belong to two different sites, like the diagram I showed you previously. So we have Amsterdam 1 and we've got Rotterdam 1 as well. Both have two interfaces, so we can see those here. One's a layer 3 interface and one's a layer 2. So we've got the peer interface between those connected. And we can also see that there's actually a cable connecting them as well, and it shows the cable that are connecting the two interfaces together. And we can see there's no artifacts. We have nothing generating configuration here as well. If we go to the interface layer 2, we can see that we have a access port. It's enabled. We can see that we've got an untagged VLAN down the bottom, which is client. That untagged VLAN is VLAN 10. It's pretty straightforward. We have IP addresses and things like that also provisioned within the platform. So they got allocated automatically using our resource manager. And what we will be looking at now is how do we extract the data we need to start building a template to automate these devices. So we've got the data in the platform, so how do we extract it? So GraphQL, it's a good platform, a good interaction point with Infrahub, and the reason being is we are a graph database under the hood, and we've been there previously where you have to query different APIs to get different things. You might have to do one query to get the devices, and then you might have to do another query to get interfaces for those devices that you've queried, depending on the platform. GraphQL is a way to be able to build a structured query that includes all the relationships, all the data you need. You can even exclude data, query, filter, and all that good stuff. And that's a great way to be able to pull all the information you need for that device in one query. So Infrahub has a GraphQL sandbox. You can open it using the admin and then GraphQL sandbox. And there's some like a README here that shows you on some basics around the GraphQL Explorer. We'll just get rid of that for now. So what we want to do is we want to query the device info. And it's very simple. In GraphQL, you do query, and we're going to call it device info. And we're going to query some things in that. So what we want to do is firstly query the kind, so the schema that we have in there that actually looks after that device. It's called dsim device. And within there, because there's multiple devices that are part of that that kind, we want to get the edges. There's multiple devices. Each one of them is an edge. The relationship is an edge, and then we can select the node that's in there as well. This will give us access to each individual device's attributes. So within the node, we can pull out the name, for example. So if we pull out name and the name has a value, you'll see it's quite structured and allows us to query the data. So if we test that, we can see we get two results back. We get two devices. We get the Amsterdam router switch, and the Rotterdam switch. But so what we can do is then start looking at how we add more data into this platform. Now, you don't have to know all of these things up front. Then you can copy and paste from the left, from the right to the left here. This interactive explorer is actually quite nice because we can show this explorer, and it will show you all the information within Infrahub and how to query it essentially. So we can go to dsim device. We can see it's already open because we're using it currently. We're going to scroll down and we can go to here. So these are the attributes of the nodes. We can pull role, serial, the OS version. But in this instance, we want to get the primary address. So I can select it, and we can see on the right-hand side, it's actually added that to the GraphQL query. And then we can access the node of that IP address and then select the address. And the address has a value. You'll see here that we also provide other values on top of just value. We have IP, which might not have the / notation at the end. We can get the net mask. So you're not having to do the calculation within your Jinja2 template anymore. Infrahub's providing that for you. So we can see here now we have the host name, and we have the primary address for both devices. So we might need this in the template going forward because we have a management address to be able to interact with that device, and we want to be able to configure that. There we go. So how do when we're building a template, templates are assigned to individual items, nodes within the database. So when the artifact is associated using a artifact definition, we attach the artifact to the node. So the queries are very singular, and what this means is that we have to be able to get this result to be only the one device's information. Now, how do we do that? So in GraphQL, we can also pass queries as if you were on REST. You can pass queries within the request. We can do that within GraphQL as well. So firstly, you can name a variable. We'll call as device. And GraphQL requires you to have like a type. In our instance, device, the device name is a string. So we're going to say, yes, we want a string. I'm just going to do exclamation mark at the end of that. That just means it can't be null. We can't give it an empty value because it's erroring, and that's because it's not used. So what we can do is actually pass this variable down to the querying of the object. And we can say, when we are querying this object, filter on the name of this object, and then pass in the variable. It actually auto-completed that for me. But if we were to run that, we'd actually get a failure. It's exactly the same on the right-hand side as what I've got typed in here. So what we actually need to do is actually pass the variable through. So you do that at the bottom of the Explorer, and I can pass the device. I can pass, it will be switch 01, AMS 01. And there we go. We can see that we have a data structure that starts with data. We can see the object, the kind. The kind has multiple different edges, and these nodes here have these parameters, and we can see it's only filtered. If I change this to RTM for Rotterdam, we can see it pulls out a different value as well. Fantastic. So to be able to make this usable in a template, we actually have the we will need to get more information. We need interfaces. We need to get if the interfaces are enabled, L3 interfaces and things like that. I'll just do a quick demonstration on what we can do here. So if I scroll back down to my device, I can see my node has an interfaces section. So we can see that interfaces section here. I can look at the edges of those interfaces, select the node, and then we can start looking at data within each interface. So I want to pull the name of the interface. If I give that a quick query, I can see that device has got 2 interfaces. If I want to see if it's enabled, I can do the same, and so on and so forth. When in Infrahub, we have a concept of generics and an inheritance of the different nodes. So we might have some values that are accessible on the higher level, but if a device is maybe layer 3, it has different attributes than a layer 2. A layer 3 interface might not have VLAN, but in layer 2 it does have VLAN. So if we want more information, we can go in and be able to select, if it's a layer 3 device, get specific interfaces, get specific information, sorry. So here I can say, if it's a layer 3 interface, get me the IP addresses, and then we can select the address from those IP addresses. And now we can see my interfaces. There's a lot of things open here, but we can see now I have, for my layer 3 interfaces, the IP addresses key, and then the edges, and then we can see the IP address of that interface. Now, I won't go through it all. There's a number of different things you can go through in the lab. I'll just copy this query over that pulls all the information that we'll use within this demonstration. So we can see we've done the same for the layer 2 side. We've got the access mode, the untagged VLAN and things like that, and the VLAN ID. Perfect. That's a quick overview, very quick. We've only got a short amount of time on this webinar, but you can go through at your own pace afterwards. So if we select next, that will take us to the next part of the lab. So in this challenge, we'll be going through how to take this data and push it through a Jinja transformation using the command line and Infrahub tooling. So just like before, we've got Infrahub, but we've got 2 other sections here now, the code editor and the terminal. The code editor has nothing in it. There's no files there. We're going to create them. So first off, we have a folder. We need a folder structure. We recommend to have some form of structure to this folder. So for example, we're going to be creating templates, Jinja2 templates. So we want to have a templates folder, for example. On the right-hand side, we've given an example of how to structure this. But as well as the templates that we need in there, we also need a .infrahub.yml file. So we store all this information in a repository, so you can version control these templates. It's not all stored in Infrahub. And Infrahub will then ingest that data from a Git repository and create your artifacts based on that. So I'm just going to be quick here. I'm in the terminal, and we can press run. This will create my basic folder structure. So if I go back to my code editor now, I can see we've got an empty template file. We've got a device info GraphQL file, and then an infrahub.yml file, all empty. So what we'll do is we'll actually just paste that query in that we had previously into the GQL file. This is so that we can tie a query to a template, so the template knows what data it's going to use to model out. So I'm just going to save that. That's saved. The guide will take you through this as well. So now we need to configure the infrahub.yaml file. So we can do this very simply. There's extensive documentation on how to structure this. But what we want is to specify the queries we're going to use. We're going to add the name of the query and then the file path that query is for. And what I'll do is just copy that file path to save time. Perfect. So all that is doing is telling the Infrahub platform, as well as the command line utility we have, that this query exists and it's in this location. And this is the name we're going to use for it. And then we can also add the template section. So in this one, it'll be Jinja2, transforms, forms, and then we'll put that information in. For brevity, I will paste it in for now. So what this is doing, it's saying we've got a transform, a Jinja2 template, essentially. We're going to call it device EOS because we're automating Arista devices. We're telling it, we're giving it a description. We're telling it the query to use when we are rendering this Jinja template, and we're saying where this Jinja template lives. So we've got a query tied to a template. Very, very good. How much customizations can we do? It's a question in the Q&A. Can any number of custom fields, IP, BGP, password, prefix, advertise, receive prefix, multiple different prefixes? You can customize it to your heart's content. We also have some of those examples available in our schema library for things like BGP and things like that. You can add as many attributes as you want to answer your question, Patrick. And just for schema library, OpsMill, GitHub OpsMill schema library, and you'll be able to see things in there. Like if we go to extensions, you'll get BGP, routing BGP, and you'll see things like BGP policies and their example schemas to use if you need. Awesome. Okay, so we've got the file now that ties a query to a transformation. So let's add some meat to the template. If we just test out the Infrahub CLI on the terminal, when we do infrahubctl render list, it just tells us that there is a render available now, and it tells us where that is. We have nothing in the template yet, but we'll show. So the infrahubctl command is a utility that allows us to test it locally before importing into Infrahub to allow that developer experience to happen. So I've got a very brief example here of a device configuration that we're going to swap, chop and change and add parameters to. But if I just save this and then run the command I have down here, which is render, that one here, we can see that we've rendered to the command line the data of the template. It's not it's not substituted anything using Jinja yet. We're going to add that. But we can see this infrahubctl render allows us to actually take the data from Infrahub and render it into the output. This will make sense more shortly. So when we have a Jinja template, there's different parts of Jinja. Hopefully most people are familiar, but we have 3 different things with Jinja. We have statements, which start with a bracket like this. And in there you can do if, for loops, and other things like setting variables and so forth. We have expressions that allow us to access the data that's been passed into the template. And this is what we're going to use first. The expression allows us to get the data, and in our Jinja transforms, the main thing we're looking for is data. Everything is passed through into the data variable, so if I put that in there, it'll look a mess, but if I render it now, hey, the result that Infrahub provided back using the GraphQL query is in our template. So let's do the first one and substitute the host name here. So looking at Infrahub, if I go back to the GraphQL query and I query it, so I need to go data, dsim device, edges, node, name, value. So I need to get that to get the host name. So I could do that, data.dsim device dot edges. And because it's multiple edges and we're only going to ever get one back, we can do .0, then node dot, I think it's that way. Yeah, node dot name dot value. There we go. Fingers crossed, demo works. Boom. No, it didn't. Where are we? Data, dsim device. Oh, edges. Node dot name. Didn't specify the attribute. There we go. And if I run that, now we can see the host name is AMS, which is for the Amsterdam. So hopefully there's that kind of makes sense. We're just accessing the data that's being passed into the template. So for brevity, I'm going to skip on ahead because of the time, but we'll go to the next one, which is to pull in the management IP address, which will be the IP address. So this one we're selecting the primary IP address, the node address value. We save that, run that in the command line. We can see the bottom has an IP address now. Perfect. So interfaces, bit more complex, uses if statements, uses for loops, etc. But what we're going to do is I'm going to just skip ahead a little bit and just copy and paste in, but so we can get forward into the meaty stuff. So I've added basically a big for loop that maps the interface name. If there's a description, it'll add the description. If it's not enabled, it will shut the interface down, adds MTU, and then checks things like if the interface is a peer role, it will add OSPF because we want OSPF between our two switches. And if it's a layer 2 mode and it's access, it will add switch port mode, switch port access VLAN, for example. And we can then test this out again, and we should see now we have one interface with OSPF and an IP address, the second interface with the VLAN configured. And I can change this to my Rotterdam device, and we should see the same output for that device. So different IP addresses, different VLANs, things like that. Perfect. We'll go on to the next stage of the thing, of the lab. In this lab, so what have we done so far? We've created a GraphQL query. Do you have any custom functions added to the Jinja2 to query easier or transform it? There's some helpers in there. Obviously, if you do pipe, I think we're looking at adding the netutils package as well, to be able to add that in. So we've looked at a GraphQL query, we've added them to the different files, we've added an infrahub.yaml file as well to tie them both together. So what we'll be looking at now is how we put all that data into Infrahub to do the end-to-end process. It's pretty simple. First off, we need a group to logically join multiple devices together. So on the left-hand side, we go to Object Management Groups. I'm going to create a standard group, and that group is called Device EOS Group. We can see that I've done this before. We're going to create that group. And what we're going to do is attach that group to some devices, and they are going to be the EOS devices. So if I just type network device and select our Amsterdam one, I'll add that to the group, and then I will add the Rotterdam device to the group. Perfect. So next up, we need to do one more thing in our artifact definition, and that is in our infrahub.yaml file, and that is to tie the group to the artifacts that we have created, the templates. So within our infrahub.yaml file, I'll just paste that in and tell you what it is doing. So what is this artifact definition doing? Firstly, it's tying, we have a name called device configuration. When we render artifacts, what is that name going to be? It's going to be called a device configuration file. The templates that we've been rendering accept, well, the query accepts some parameters, and that parameter it accepts is device, and we're going to get that from the name of the device that this is being run against, and how we query that is name __ value. When we render a device configuration and attach it to a device, we're going to have it as a plain text content type. You can also do YAML, Markdown, JSON, I believe, for different use cases. And then when this gets rendered, or how we target an artifact to be generated, is we're tying this artifact definition to that group that we've just created. And then finally, this artifact definition, when it's triggered, will Run the Jinja transformation that we've just defined as well. Perfect. So for us to get this into Infrahub, we need to have a Git server available. We've got one locally set up in the lab for you. You log in via Infrahub. And we can see we've already got a repository in there for you to use. I'll just exit these. Yeah, there we go. So we can see it's called Infrahub repo. It's a blank repository, nothing there. So what we're going to do is just commit these changes that we have in the CLI that we've done up to that repo. So if I just navigate to the terminal, press run on this right-hand side, and we go back to our Git server, do a quick refresh here, go back into the repository, we can see our infrahub.yaml file, and we can also see our templates. Perfect. Now, how do we get all of this juicy stuff into Infrahub? And how we do that is Infrahub is able to read repositories. So we can do that now. So we go to unified storage. Firstly, we need to create some credentials so it knows how to talk to the Git server. So if you have a private instance, it'll work just fine. Going to create one called Git credential, same username and password as the Git server. So we've created a credential. Now we go back to repository, that's unified storage repository. We create a repository. We've got the URL in the guide on the right hand side. We specify the Git credential. I'm just going to call it Git repository, and we're going to press save. Perfect. Now what this will do under the hood is it'll go to our Git repository, suck in all the information, and then it'll create nodes within the database. So it'll create the query, it will create the template, and tie all those together with the artifact definition. So if we go in here, we can see it's syncing. We can see there's tasks running in the background. If I just give that a quick refresh, yeah, it's in sync now. So this is, see all the tasks that happen in the background. We've got a query. You can see that query looks like the one we had earlier, and you can open it in the GraphQL sandbox if you need. We have the template. If I go back to repository, sorry, you can see the transformation is in here. The Jinja2 transformation is in here. Perfect. So what we can do now is if we go to our artifact definition, and that's deployment artifact definition, and press generate, what that'll do is kick off the artifact generation in the background and attach those configurations based on the main branch within Infrahub so that they are available on the device. So we can see here it's already run and we've got an artifact attached to a device, and we can see that rendered configuration for the device. So we've verified it's working, and what I'm going to do is skip to the next step, and that ties in together the uniqueness of Infrahub, where it is a platform. So we've created a GraphQL query, we've created a Jinja template and Jinja2 transformation. We've created a group that ties those objects, those nodes, to an artifact definition, so that when it changes, artifacts will be deployed. So that's what we've done. And now we're going to look at the end-to-end workflow. The anonymous attendee that asked if it's possible to define local variables. Of course, yes, but I wasn't covering this within here. Yes, you can set your own variable for a device, and without the long strings, of course you can. Yeah, perfect. So we're going to run through a common change. Now we've got artifacts in Infrahub. So what we're going to do is create a new branch, new interface. Going to create a new branch. Branches are important as it allows us to edit the data in the database without affecting production. If you've got automations tied to this, we can make proposed changes and see things in action. So what we can do here is we've got a branch now, and it looks the same, just different part of the data. It's just like working in Git. And what we're going to do is, firstly, we're going to create a new VLAN. We've got a few minutes left, so I'll try and be quick. I'm going to create a VLAN. Yeah.
Just there's a few questions also on the Q&A.
Yeah.
So while it's going, maybe we can answer a few of them.
Yeah, of course.
So there's one question about the custom function Jinja. I think you already answered this one.
Yeah, I think I've already covered that. If you're creating multiple pieces of configuration in different templates within the same subsection of router like BGP, is it able to piece them together? Yes, we can do Jinja2, like I think it's like the import. We can do that. So if the files are like a lot alongside each other and you're able to map the paths, then definitely it will import from other locations. Can you add more than one template? Yeah. That kind of covers the last question. Yes, you can. So for customers, for example, we have one maybe for the overall device that will inherit from a BGP section, and then maybe from a VLAN section that allows us to also have different BGP configuration based on device role, for example. So you might say this is a peering router, so we want this specific configuration. Yeah, we can do that.
On that, maybe Alex, interesting to highlight that it's actually not tied to devices. Like you could have,
yeah, exactly. Yes.
We could have what we call those transformation to any object. So you could use that to generate a cabling plan on the site. You could use that to generate information on a specific BGP session or anything. And I think the other point that might be good to remember everyone is that it's actually not specific to Jinja. While this webinar has been shown on Jinja, we can also use Python code to generate anything. So it could be JSON, it can be, we can generate CSV file, XML.
Yeah, exactly. Yeah, it's funny you mentioned that, Damien. The end of this lab, it's got a section called Beyond Network Configurations. We are not only, you can tie an artifact indeed to anything, so you can create security policies in JSON using the Python transform. You can create DNS server configuration for like Linux servers. We've got a customer at the moment looking at generating infrastructure as code templates, like Terraform templates as well. Documentation cable plans using CSV is what we have experience with as well. So yeah, you can be very flexible with these artifacts.
Thank you. Thanks, Alex.
So I'm just going to finish off this by adding a new interface. I'm going to add a new interface, Ethernet 3. It's enabled. It's going to be an access port.
Sharing right now.
Sorry?
You need to reshare your screen, if I'm not mistaken.
Oh, can you not see it?
That works for me.
Oh, okay. Sorry, I'm not seeing.
Perfect. Right, I'll try and... Oh, there we go. I'll just finish this one off. Speed, quickly, and we'll associate this new interface to our Amsterdam device, and it will have the untagged VLAN of IoT, which I just created. What I can also do is go to another device, let's say Rotterdam, and alter one of the interfaces. So instead of connected to a server, I might say it's connected to the intranet, if those are still around. So now we have a branch with our proposed changes in, and now we can kind of create a like a request to propose that change back into main. New interface, and this shows what we're showing here is the pipelining within Infrahub. So we've defined the GraphQL query, the artifact, whether that's a Python or Jinja2 templating that we're using. And under the hood, when you generate a new proposed change, it'll first figure out what you have changed within Infrahub. So it'll see we've added interfaces, we've updated things, and it will only run the artifacts against data that's changed. So we're not just generating configurations for everything. It will only generate configurations for the devices that have changed. So shortly we should see artifacts that pull into here that we can see. So while that's going, if all the configuration files created individually would be pieced together into a single file for the device, which would be similar to, yeah. Brett's responding to you there, Julian. So we've got diff, and fingers crossed, our tasks have complete. So artifacts are now available, and we can see Infrahub knows there has been a change to this device based on the GraphQL query. So we can see that now the artifact is tied to the device or the node, and we can see it's changed, so it's generated a new artifact. But this is in the branch. We can see the other device had a new interface added because we defined a new interface on that device. And if we go back to main and look at those artifacts for those devices, they are still the original artifacts. So your production wouldn't be changed. The artifacts are in that branch. And if we were to merge it, it would regenerate and ensure that the main branch has the updated artifact in it. And we can see that now. So we go back to the network device, go to Amsterdam, see the artifact. We can see it now has 3 interfaces. Perfect. Hopefully that's a quick overview. We will be doing a webinar shortly on how to take this artifact and deploy it to the network using either Ansible or Nornir, and we'll be labbing up this actual network as well to deploy to it using Container Lab. So we'll show you how to interact with the Infrahub to pull this configuration and push it to a device. While that is there, if anyone wants any more information about this, let me just share this. The lab can be accessed by scanning the first QR code. Suresh from Packet Switch has also done a blog around how to generate artifacts as well for the similar device configurations. And also there is a blog that's recently been released by our colleague Baptiste that looks at how to use Infrahub in more of a service catalog way, which may be of interest. So hopefully, if you're interested in taking part in the labs or reading any of those articles, feel free. Give them a quick scan on your phone or take a picture.
Like there's another good question there.
Yes. Can I import data for Infrahub branch from elsewhere? CSV YAML from Git with verification according to data models in Infrahub. How do you handle data model changes from branch to branch? So the first question, can I import data from another source? Yes, you can. We have actually a pretty cool project called Infrahub Sync that can synchronize data from other platforms, whether that be Slurpit or we have some other integrations with other platforms like Peering Manager and so forth. And how do we handle data model changes from branch to branch? So we recommend that obviously when you're doing schema changes, that you do schema changes in a branch, and then during the proposed change, we'll highlight any changes that need to be done to the main schema, and the merge will take care of the kind of transformation within the model. Before changes are merged from branch, can you specifically query data from the branch via the API to test outside of Infrahub? Of course, yes. Our SDK, our GraphQL API are all are aware of the branch, so you can query for main against the branch you're working on. But another aspect that we're not talked about in this, it might be another webinar, is that we can also implement checks into the pipeline. So if I just highlight my lab again, I don't have a proposed change up at the moment, but you can also add checks into the pipeline to either say that your Jinja is compliant and is has what you need in it, or data within the platform is specifically configured or compliant as well. So you can add checks to that kind of pipeline as you would with like a Git CI pipeline as well. How is Infrahub handling its data backup? So it is a database on the back end, and you can either do things like backup the containers physically, it is deployed in container, or you can export the data from the database and store it by dumping the database, similar to other platforms. How to manage versions of Infrahub. We currently have Docker images, and if you upgrade the Docker image when it boots up, it will do the migrations automatically and upgrade. There are some caveats with that. We try and be good with our changes. If there is any changes that might break schemas and things between releases, we'll hopefully be aware and let you know. So if there are any changes like schema deprecations or changes to the schema, these might have an effect, but yeah. Can we migrate easily from another source of truth? You could. Our Infrahub Sync library has the ability to synchronize with some other common sources of truth or data platforms. So you're able to synchronize some data across, yes. And it also allows the ability to map the fields dynamically. So you can say the source to the destination, maybe in different column names, and you can map that. You have to map it once, and then the synchronization will run. So hopefully we've given you a quick overview of using GraphQL and artifacts within Infrahub, and using the pipeline process to merge that in. As I said, there will be a future webinar and lab to go with pulling this data out and actually pushing it towards a network device that follows exactly kind of the data that we have as a result in this platform. It will follow on as like a continuation of this lab. So as you're learning the Infra platform, you can go from one to the other. Thank you very much.
There's actually a last question.
Oh, someone's got in there at the end.
The spicy one.
It looks very similar to Netbox. What would I get with Infrahub? It's a very good question. I think that each have their own benefits. Infrahub is built on a lot of learnings from Infrahub, from Netbox, sorry, and Nauto. As Damien's here, who has worked extensively on both, what do you think, Damien?
Yes, I can take it. So I think that the main point, the two big differentiators are, the fact that Infrahub has a very, very flexible schema. I think that's really been where people are seeing the main interest, the big interest right now, where I think in tools like Netbox, you can add custom fields, but there's always this core schema that you have limitations on, and you can also create your own plugins, but it adds more work. With Infrahub, really, it was not necessarily displayed here because the schema was already loaded and all, but if you actually create your own schema, you'll just have to create the YAML files, and in Infrahub, you automatically get the APIs, the UI, everything is automatically customized for you, and there's really no core schema. Like the core schema that we have is the one that is just at the bottom of the menu, so it's just the internal object that we use to make it work, but there's really no core schema for the data that you care about. So we have a lot of examples out there, so that's the main one. The second one is version control. So version control is completely built in, and every feature supports it, and everything was built around version control. And yeah, that's probably the two main ones. There's more. I think
I was going to say resource manager. That's a really good one.
Yeah. Also, like there's definitely a lot of things that have been built, specifically around infrastructure management, like the transform that we showed. With version control come also the proposed change and the peer review process is built in. So there's definitely a lot of differences.
Question there. I would not even look at it without integrating version control. That's why we have version control. So we can make those proposed changes and have the flexibility of being able to see changes. Are you working with some major vendors out there for integrations? Like Netbox has an inventory plugin for easily available. Yes, we are working with the major vendors. So for example, that follow-on webinar and maybe and lab will showcase some of those integrations. We do have the Nornir inventory, we have Ansible inventory, we have Ansible modules, we have an extensive Python SDK, and we're working on other integrations as well, like Pliant, and maybe some others in future.
Fun fact is, actually the initial author of the Ansible inventory for Netbox and the Nornir inventory for Nornir are actually part of the team.
Yes.
Looks like we had like an amazing number of questions. Just as a reminder, aside from the documentation and these labs, we also have a Discord. So that's another great place to jump in if you have ongoing questions that you want to ask. So, please join the community and ask there as well. Maybe we have time for one more, and then we'll probably, we're hitting the top of hour, and we'll close after this question. But please, join the community and ask there too.
Yeah. So that last question, I'll quickly cover it now. What about netbox scripts? Do you have the equivalent to create a HTML form to trigger a pipeline in GitLab or equivalent? So what we have is the ability to create like what I mentioned earlier, like a service object. So for example, you might say, I want to add a firewall rule. You can create a schema that defines that kind of entry logic. And what will happen is when you add the inventory, let's say the kind of attributes you want, inherently by default, Infrahub will create a form, the UI around it. And then what you can do is integrate that kind of service object with what we call a generator. So when that service object changes, that during the pipeline of a proposed change, it will take the output of that service object and then do a number of different things. It might go and create new nodes in the database and things like that. It's just like a kind of a netbox script that might create nodes in the database or might talk to external systems, etc. But yes, you can do it, and we're using it for a lot of our customers. They're called generators. So have a look in docs.infrahub.com. Just make sure it's that. Infrahub.app and search generators. And that will give you an overview of how generators work. Perfect. We're going to call it there, but as Alex said, jump into our Discord, ask any questions you feel are necessary.
All right. Well,
Thank you very much.
Yeah, thanks, Alex. Thanks, everyone, for taking part today and for all the great questions. Love to see it. So, and look for more in-depth, kind of webinars on topics like this coming soon, as well as some things on some very cool product updates that are imminent. So stay tuned for all of that. Thanks, everyone. Have a great day, and see you in other venues, online and elsewhere.
Thank you.